But what is it really? Why are governments, tech giants, and physicists investing billions into machines that don't even work like traditional computers? In this video, we're going to break down what quantum computing is, where we are today, and how this strange technology could change the future of everything, from medicine to AI. Let's dive in. What is quantum computing? In classical computing, everything comes down to bits, zeros and ones. These are like light switches, either on or off. All modern technology, from smartphones to supercomputers, is built on this binary logic. But quantum computing uses qubits, quantum bits, and qubits can exist in multiple states at once, thanks to a strange quantum principle called superposition. Imagine flipping a coin and it being both heads and tails, until you look at it. That's superposition. Then there's entanglement, where two qubits become linked. Change one and the other reacts instantly, even if they're miles apart. This allows quantum computers to handle incredibly complex calculations with far fewer steps than classical machines. Where we are now. Right now, quantum computers are still in their infancy. Most machines only have between a few dozen to a few hundred qubits, and even those qubits are fragile. They must be kept near absolute zero to avoid errors. In 2019, Google's Sycamore quantum processor made headlines when it reportedly achieved quantum supremacy, completing a calculation in 200 seconds that would take a classical supercomputer 10,000 years. But that victory was symbolic. Today's quantum computers still can't solve useful problems faster than classical ones. Yet, what we're seeing is the foundation being built for the next generation. Current and potential applications. Even at this stage, quantum computers are being tested for powerful applications. Some of the most promising areas include drug discovery. Quantum simulations could model how molecules behave, speeding up the development of new medicines. Material science, discovering new materials like high-temperature superconductors. Logistics and optimization, solving massive route planning or supply chain problems that traditional computers struggle with. Machine learning, enhancing AI training by evaluating enormous data patterns in parallel. Cryptography, quantum computers could break today's encryption or invent new unbreakable ones. These are just possibilities, but serious ones. Fortune 500 companies and governments are already investing millions in quantum R&D. Challenges and roadblocks. Despite the hype, huge challenges remain. The biggest one? Decoherence. The tendency for qubits to lose their quantum state due to outside interference, even from a stray particle or vibration. Most current quantum computers only maintain coherence for microseconds. Then there's error correction. Quantum systems are extremely sensitive, and it can take thousands of physical qubits to produce a single error-free logical qubit. Solving this is key to building large-scale, practical quantum machines. The road ahead. Despite the obstacles, progress is steady. IBM plans to build a 1,000-plus qubit system by 2026, and ultimately a million-qubit machine. Companies like IonQ and Rigetti are taking different paths, using trapped ions or superconducting circuits to scale up. We'll also see hybrid computing models, where classical and quantum machines work together, combining their strengths. The next 5 to 10 years will likely bring quantum acceleration to specific industries, with general-purpose machines still a bit further off. Why quantum matters? Why does all of this matter? Because quantum computing has the potential to reshape the world as we know it. It could unlock cures to diseases, new energy sources, next-gen AI, and climate models we've never been able to simulate. It could also force us to rebuild the foundations of cybersecurity. We're not there yet, but we're getting closer every day. Quantum computing is one of the most exciting and misunderstood technologies of our time. Where we go next depends on the breakthroughs happening now. What do you think quantum computers will solve first? Drop your thoughts in the comments. Like if you learned something new, and hit subscribe for more mind-expanding science and tech content.